Hi, I'm Chem's best friend. I make chemistry easy. I'm a graduate of MIT, and I have more than 17 years of experience teaching AP chemistry and chemistry classes. Please like and subscribe to my channel. And if you are interested in private tutoring lessons, the information is on the screen. Hi, I think today is a perfect day to learn more about acids and bases, especially the pH scale. Are you ready? Let's go to my screen. In a previous video, we talked about water, that it can be acid or a base. It can be both. And if water can be both, we have a special word for it, amphoteric. Let's look at this picture. Here we have one water molecule and another one. What's going on? This water molecule is giving up its H+ to this one. And this water molecule here is accepting it. So therefore, do you remember our definitions of acid and base? The water giving up an H+, this one is acting as an acid. And this one right here is accepting an H+, so it's acting as a base. Once the one acting as an acid gives up an H+, it's going to be a conjugate base. And this one here accepted an H+. Now this one has the ball, right? So this one right here will be now our conjugate acid. So water can be both, acid and a base. Keep that in mind. Also, I want to mention that H3O+ is the same as H+ ion. H3O+ is called hydronium ion. I want to show you why. So when we have a water molecule, remember there's a lone pair of electrons here and a lone pair of electrons here. When we have an H+ by itself, there's no way it can swim by itself between water molecules, because right away these electrons here will be so attracted to it that it will attack it and attach it to the water molecule. So here it is. So H+, as I call it, a lazy chemist way of writing H3O+. Everyone understands that H+ doesn't exist by its own, but we can quickly write that. Okay, are you ready for a little bit more? So, we said that water molecules can split up into, an H+ and an OH. So let's write this. We have our water molecule. It will split up into an H+ plus hydroxide ion. And this happens on its own 1 in 10 million. 10 million water molecules, 1 in 10 million, will split up. Wow. Maybe you think it's a lot. Maybe you think it's not. We will see what it means. So right here, let's talk a little bit about hydrogen ion concentration. And right here, we will talk a little bit about hydroxide ion concentration. And you will see that whatever I do to hydrogen ion, it's going to happen the same to hydroxide, just because it's a 1-to-1 ratio. So how can I write 1 in 10 million? So if 1 in 10 million water molecules splits out, I'm going to have 1 in 10 million hydroxide ions swimming, 1 in 10 million hydrogen ions swimming. So I'm going to write 1 in 10 million. I can also write it as 1 over 10 million. I can also write it as 1 over 1 times 10 to the 7th, yes? 10 million is 1 times 10 to the 7th. I can also write it as 1 times 10 to the -7. And hopefully you can see it is the same thing here. So I'm going to have 1 times 10 to the -7 hydroxide ion. Let's keep going. So that means if I write my equilibrium expression, I can write my Kw. This equals my H plus concentration times hydroxide concentration. Well, I had 1 times 10 to the negative 7 times 1 times 10 to the negative 7. That's a special number. That's 1 times 10 to negative 14. 1 times 10 to negative 14. This is important. Let's put it in a red box. Okay. And speaking about these exponents, it's a little bit, I don't know, hard to keep in mind. So somebody came up with this definition. Let's say we will have power of H. Power of H plus ion scale will be negative log base 10 of H plus concentration. And then, if we follow the same thinking, we will have power of OH, right? Power of hydroxide. We're going to have negative log base 10 of hydroxide ion concentration. Do you know how to do this? It's 10 to what power here gives me this number, right? So if we're going to do our negative, flip the negative, multiply everything by negative 1, we will have 10 to the negative 7 power gives me 1 times 10 to the negative 7, yes? So this is pretty important, very important. Let's put that in our red box. And that also means that for water, or actually any substance, we have pH plus pOH will equal 14. So here we go. Just because H plus times OH minus concentration gives us 1 times 10 to the negative 14. So here we go. So now you know that the pH scale, why is it based? Why is it based on from 0 to 14? Because it's not just somebody woke up and said, oh, I like these numbers, and I like 7 to be neutral. You can really see that if you plug in these numbers, let's plug this in here quickly. So what if we have, what is my pH of negative log base 10 of 1 times 10 to the negative 7? You will see that for water, pH is 7, and the water is neutral. And that means for our water, pOH is also 7. It's based on auto ionization of water. It's based on nature. It's not just somebody says, I like these numbers. So let's look at our pH scale. And I really like this picture. Over here, I really like this because it shows you that everything below 7, so remember what our hydroxide ion, hydronium ion concentration is. So this is, if we're going to talk about our H hydronium ion concentration, here we have 1 times 10 to the negative 1, 1 times 10 to negative 2. And you can see that these numbers are getting, as I'm going up on my pH scale, my H plus concentration is going less by 10. So if I go, how much more acidic is my, let's say, tomato juice to lemon juice? How much more acidic is lemon juice? Lemon juice has pH of 2. Tomato juice has pH of 3. How many times is lemon juice more acidic? It is 10 times more acidic. If I go here, let's go, how much more acidic is something with pH of 1 from pH of 2? That's also 10 times, because it has 10 times more H plus ions. So if I go from 3 to 1, this will be 100 times more acidic. pH of 1 is 100 times more acidic than something with pH of 3. So as we go down, as we go right here, the H plus concentration increases. And as we go here, my H plus concentration decreases. And here my H plus concentration increases. And you can quickly see that anything that's acidic, it's mostly foods. We can deal with foods. And the basic things is cleaning products, as we said in the previous video. Let's go here. And right here, I love this picture because it shows you a little bit more. So here is, just look right here. Anytime you have any substance, the pH plus pOH will equal to 14. Yes, so 3 plus 11 is 14, 5 plus 9 is 14. And at the same time, your H3O plus or H plus concentration times OH minus times hydroxide concentration will be 1 times 10 to the negative 14. So this really shows you nicely. And then, so our acids are here, flipped from the other picture. Acids are going up. This is getting more acidic as we go. And you can see that our litmus paper is red. Bases turn litmus paper blue. And as we go down here, it becomes more and more blue, more and more basic. And our pH is increasing. Then the number, pH number is increasing. The H plus concentration is decreasing. And here it is, it's decreasing by 10. So I hope this table makes sense to you. And to really check if you can deal with this, let's throw in some numbers. Let's see if you can fill in this table. So I filled in some numbers here and see if we can do this. If I give you H plus concentration, can you tell me OH minus? Can you tell me pH? Can you tell me pOH? And can you tell me if it's acid or base? Keep in mind these things. These things are really, really important to maybe have it memorized. And I need you to notice you can always find out your H plus concentration if you do 10 to the negative pH. You will get your H plus concentration, and 10 to the negative pOH gives you hydroxide ion concentration. So let's do the first problem. Let's throw some numbers in here. If we have 3.42 times 10 to the negative 4, can you find out, can we figure out our OH minus concentration? I think so, right? Let's go write some numbers down. Well, remember, if we do right here, right? If we do 1 times 10 to the negative 14, divide by what's given, we will have our OH minus. So we will quickly do 1 times 10 to the negative 14 divided by 3.42 times 10 to the negative 4, and this will be 2.92 times 10 to the negative 11, and that's my OH minus. Yes? And do we know our pH? Well, do you remember pH? Let's take our calculator and take negative log of our H plus, and here is our H plus. Take negative log of this number. So our pH equals negative log of 3.42 times 10 to the negative 4. And this will be 3.47. And what is my pOH? Well, pOH, I can do both, either one of two things. I can take the, well, let's go here. Look at this. So pOH is negative log of OH, and here's my hydroxide ion. Here it is. I can take negative log of this. Or remember, pH plus pOH equals 14. So 14 minus my pH, and this will be 10.53. So let's fill in the numbers that we found out. So here we're going to have 2.92 times 10 to the negative 11, which one is greater, H plus or OH minus? Right? H plus is bigger, so this one tells me also it will be an acid. pH is 3.47. The numbers make sense. It's below 7. Below 7 is acidic. And pOH, whoa, pOH, let's go here. pOH is 10.53. Okay, could you follow this along? Let's do the next one. Here I'm giving you OH minus concentration. Can we fill in the numbers? Well, I think so, right? To do our H plus, we're going to again take 1 times 10 to the negative 14, divide by what we are given, 5.67 times 10 to negative 3, and we will get 1.76 times 10 to negative 12. So quick question, if it's 10 to the negative 12, my pH should be very close to that exponent, right? My pH should be close to, so my pH should be somewhere around 12. So if I take the negative log of my H plus, I'm going to get pH. And pH negative equals negative log of 1.76 times 10 to negative 12. And this is 11.75. Very nice. And then pOH is 14 minus. So my pOH will then be 2.25. So let's fill this in, what we have. Okay, so my H plus was 1.76 times 10 to negative 12. Here we have pH was 11.75. pOH was 2.25. Well, what do you think? Acidic or basic? Well, I need you two things to look at. pH is more than 7, so it's a base. But also, my OH minus concentration right here is bigger than my H plus. If my OH minus concentration is bigger, then it's a base. Here you go. Okay, now we have 8.7 given as our pH. So right away, we can actually answer, is it acid or a base? So pH more than 7, base. How are we going to deal with this? Well, if we're going to do right here, have a look right here. I'm going to go right here. Yes, so I can do lots of things. I can fill in any way. So if I do 10 to the negative 8.7, I'm going to get 1.995 times 10 to the negative 9, which is very, very close to 2 times 10 to the negative 9. And then if I do, again, 1 times 10 to the negative 14 divided by this number, I'm going to quickly get my OH minus hydroxide, as I'm going to get 5.012 times 10 to the negative 6. And my pH was given 8.7, but my pOH 14 minus 8.7 will be 5.3. So I can fill it in out on a table. So here will be 5.3, and here will be 1.995 times 10 to the negative 9, and here will be 5.012 times 10 to negative 6. How did you do? Let's go here. If we have pOH 2.5, pH is, well, 14 minus 2.5, 11.5. Okay, 11.5, pH, acid or base? Base, right? Base, more than 7, it's a base. And we can fill in the numbers. So try to do this. So if you have this, 2.5, we can do quickly. Let's go here. We can do 10 to the negative 2.5. 2.5 will give me my, hold on, pOH, and then my OH minus concentration. My OH minus concentration, and this is going to be 3.16 times 10 to the negative 3. And then my H plus, I can do 1 times 10 to the negative 14 divided by this number. I'm going to get 3.16 times 10 to the negative 12. Wow, it's a coincidence, but let's fill it in. So here I'm going to have 3.16 times 10 to the negative 12. Here I'm going to actually have 3.16 times 10 to negative 3. And I can see that my OH concentration hydroxide is more than my H plus concentration with my hydronium. So it's also a base. So did you learn anything new? Does this make sense? Can you fill in a table by yourself? I hope you can. And see you next time.